Welcome to 5G Hub. In this video, we will talk about narrowband IoT communication process. In last video, we discussed the narrowband IoT random access procedure. Today, we will explain the entire communication process. The LTE Radio Resource Control or RRC protocol has only two states, RRC connected and RRC idle. In RRC idle, these states indicates that the signaling radio pair is not established. This meaning no RRC connection is established. And here the device monitor the control channels to determine whether any data is scheduled for communication or not. And the device in this state performs neighboring cell measurement, cell selection or reselection, and also will collect measurement report and acquire system information. The second state is RRC connected. This state indicates the signaling radio pair is established. So RRC connection is established, and in RRC connected state, transfer of data to and from the user equipment takes place. In narrowband IoT, also the device has the same two states, RRC idle or sleeping state and RRC connected or connected state. The handover has been removed because this is standard was designed to be simple by reducing the sophisticated operation of LTE functions. In narrowband IoT, like in LTE, whenever a device wishes to transmit new data and doesn't have any active connection with the network, it needs to follow the connection established procedure, and this procedure is made up from the random access procedure and attach procedure. To establish a connection, the device begins to scan the air interface for a suitable network to connect it to and synchronize with it in the downlink direction from the network to the device. Afterwards, the random access process is followed to gain synchronization in the uplink. This meaning from the device to the network and request resources for transmission, which started with the preamble transmission by the device. For each identified preamble, the base station or the site replies with a random access response, as we discussed in the last video, that contains an uplink grant for the next transmission and the device specific timing advance to control subsequent uplink transmission or how much time in advance the device needs to start transmission, so that the site can receive the signal at the correct time. Next, the base station resolves possible collisions that might have been happened at the preamble transmission stage and select the device that are allowed to proceed with connection establishment process. The devices then need to follow attach procedure. This meaning establish a connection with the core network, generate security context, and also establish radio pair. The second step is the user equipment or the device started to the attach process. The device now can exchange data between user equipment and core network. After the data transmission, devices remain connected to the network for a specific amount of time called active waiting. This feature was initially designed to avoid having to repeat the connection establishment process when the devices exchange data within short periods of time. The duration of active waiting is defined by inactivity timer, which is a network operator specific, maybe from 10 to 50 seconds in most commercial networks. After expire of the inactivity timer, the network releases the connection and the device is switched now to idle or sleep mode state, with low energy consumption, requiring the device to repeat the connection establishment process when it needs to transmit data again. If data arrives while the device is in idle state, the network uses the pages or the paging procedure to notify the device. Additionally, as we discussed before, the power saving mode feature can be used. This allows the user to enter a sleep mode and operate with consumption close to power off. Thank you for watching and see you in next video.